Hello everyone. Today I would be discussing Leetcode weekly contest 384. And I was able to solve all the four problems, so I would be discussing all four of them. Before we get started, can anyone confirm if audio and everything is fine? Okay, thanks Akash. Let's start with the first problem. First problem says given a zero index m into an integer matrix, create a new zero index matrix called answer. Make answer equal to matrix and then replace each element with the value -1 with the maximum element in their respective columns and return the answer matrix. So for example, if you look at this matrix, like there is no -1 in this column. There is only one -1 in this column. So you should find the maximum integer in this column, which is 8, and replace it here. And here, like there is one -1, so you should find maximum number in this column and replace that with this -1. So here it would be 9. And this would be our final matrix. Similarly, in the second example, like first column does not have any -1 and second column has one -1. So like the other number remaining number would be the only maximum number in this column. So you should replace it with over here. And like what happens in case like all the integers in a column is -1? That won't be possible because it says like input generated such that each column contains at least one non-negative integer. And like the code I did was pretty much exactly what the problem statement asked. Created a copy of the matrix for x in v for v in matrix. And then I found like with the values of n and m, which would be length of a and the length of first sector. Then I iterated on all the columns for j in range m and maintained a variable which is maximum. Now iterate on all the rows to find the maximum in this column. Mx would be max of mx comma aij. And then now iterate on all the rows again, and wherever -1 exists, replace it with the maximum in that column and you would get the final matrix, return it. And like that, pretty much this was the code for the first problem. I will now move to the second problem. Second problem says you are given zero index integer array nums of length n. A zero index array pattern of size m consists of integers -1, 0 and 1. A subarray num ij of size m plus 1 is said to match the pattern if the following conditions hold for each element k. Num I plus k plus 1 is greater than num I plus k if pattern value of kth element is 1. If both of them are equal, then the value for the pattern is 0. And if I plus k plus 1 is less than I plus k, then the pattern value is -1. And now we have to count the number of subarrays in num that match the given pattern. So for example, like let's look at sample first. Like for example, if we look at the first sample is 1, 2, 3, 4, 5, 6, and the pattern is 1, comma 1. So we should find all the substrings such that like bi b1 is less than b2 and b2 is less than b3. Like basically overall we need is b1 less than b2 less than b3. The three continuous numbers. And if we look at over here, like this subarray satisfies this condition, so this would be the first occurrence. This subarray satisfies this condition, so this would be the second occurrence. This subarray also satisfies this condition, so this would be the third occurrence. And this subarray also satisfies the given condition, so this would be the fourth occurrence. So overall the answer would be 4. Similarly, if we look at the second condition, like the numbers are 1, 4, 4, 1, 3, 5, 5, 3. And what we need is the pattern is 1, 0, -1. So by 1 we need like the new subarray. If we call the subarray as b, Then b1 should be less than b2. Negate b1 should be less than b2 because 1 is exists, and b2 should be equal to b3 because we have a 0 over here, and b3 should be greater than b4 because we have a minus 1 over here. So like we have to count all the subarrays which satisfy b1 equal to b2 equal to b3 which is greater than b4. And if we look at the original array, like this is one place which satisfies this condition, and if we and like this is the other place this satisfies this condition, and these are the only two subarrays, so the answer is 2 over here. So like we can simply try to brute force it to see like for all the starting positions, like if a particular subarray satisfies some pattern based on the given condition, and like this would essentially solve this problem. Like our conditions, like we have to find like subarray of length m plus 1. So this should hold. Now we can start matching over here. If pattern j is equal to minus 1, and then now we need is now if nums pvr is less than if nums pvr is greater than nums current index, then we should continue. Otherwise we say that match is false. Similarly we can code for the other values of the pattern. And at last if match is true, we do answer plus this. And like this would solve the second problem. Now moving to the third problem. It says you are given zero index string words having length m and contains zero index strings. You are allowed to perform following operations including any number of times including 0. Choose integers I, j and xy such that I is less than j is less than n, and 0 is greater than equal to x is less than words, like 0 is less than equal to x is less than equal to the length of words I, and 0 is less than equal to y is less than equal to the length of word j, and swap the characters. Okay, can you please explain the second problem again? So the main problem for the second problem was like the constraints were easy, like very small. So for this problem, like you can brute force all the starting index where the num starts. Like you can try for all the starting values of I and check all the subarrays of length m plus 1. And for each k, you can check if these conditions holds or not. And at last, if this holds for all the k, then you should print a true and false over there. So like I started with like checking all the values of length m and then all the possible values of k which I am denoting by j, and then I'm simply checking all the conditions that were mentioned in the problem statement. Like I won't call it a sliding window just because there are two pointers over here. And like the harder version would be the second fourth problem, which it was like where a brute force algorithm like this won't match. So like maximum palindromes after operations, you are given zero index array word array words, each having length m contains zero index string. It says we can do following operation any number of times. And this statement essentially means we can pick any two characters among all the words and we can swap however they want. And we have to return an integer that denotes maximum number of palindrome words that can contain after following some operations. It also says like we can swap any two characters in the same string as well. So like for example, if we look at the given samples, in the given samples we have been given A, B, 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 A, A. And notice that this is already a palindrome. And like for example, if you swap these two characters, this string would be A, B, B, A, and this string would be B, B, and this will also be a palindrome. So the answer is 3 in this case. So the answer would be 3 in this case. In the second sample, if you look at it, A, B, C, A, B is there. And like if you like the first thing you can do is like C appears only once. So you should make C over here, like swap these two characters at first. So the strings would be A, C, B, A, B. Now you can also swap like this B with this A, and the final string would be A, C, A, B, B. And both of these are palindromes, so the answer is 2 over here. And like for example, if you look at the third string, it says C, D, E, F, and A. You can notice that all the characters appear only once. So like irrespective of however you swap words over here, you will not be able to make a palindrome. While this is length 1 palindrome, so like the answer is 1. And now let's analyze like how does a palindrome happens over here. Like for example, you have string S1, S2, S3, S4, S5. Then for this string to be a palindrome, S1 should be equal to S5, S2 should be equal to S4, and S3 can be any character. So you need two characters that are even times so that you can have S1 equal to S5 and S2 equal to S4. And you can add any character as the third character. And if you notice S1, S2, S3, S4, S5, S6, S1 should be equal to S6, S2 should be equal to S5, and S3 should be equal to S4. So now here you need three characters that appear even times or two times. Like the main idea was if we have an odd length L, then we need one character in the middle. And apart from that, we need L by two different characters. Its floor that can appear in prefix and rewards suffix. And similarly, if the length is odd, then this is the only condition we need. And because we can swap any two characters we want, Okay, so like to summarize again, what we need is, like if we look at like even palindromes, you will notice that the first and last character should be equal and the second and second last character should be equal. So overall, you would need two characters that appears two times or one character that appears four times for the even part. And like anything can come as a third character. And the other thing to notice was, if you try to check the even characters, first and last character should be equal, second and second last character should be equal, third and third last character should be equal. So like we can have three different characters which appear two times. We can also have a case where we pick one character which appears four times and one character which appears two times. Or we can take a character that appears six times. And then because any swaps are allowed, we can rearrange to make them a palindrome. And if the length of character is odd, then we need one character which appears odd number of times so that we can put it in the middle. And apart from that, all the characters should appear even number of times. And like if that is the case, then we can rearrange it however we want. To take some example, let's say like we have a five character string a b b c, then we can rearrange it by making swaps to make a palindrome a b c b a. Or we have a character like string like this, then also we can rearrange it to make it a palindrome by swapping the characters over here. But let's say if we have a 6-digit character, then this is a palindrome. Then if this is how the string looks like, then we can also make it a palindrome by rearranging. If this is how a string looks like, then we can also make it a palindrome by rearranging characters over here. And like if all of them are B, then that's also a palindrome. So like the main crux of the idea is, for each string we assign the characters and how many times we want to pick a particular character. And then once we have finalized it, we can swap those characters however we want to make it a palindrome. And like that is the first part of this problem. And now notice one more observation was, like let's say your final answer contains string, like let's only care, say that we only care about the length of the string and how many times a particular character appears among all the strings. Because if we know it, then we can assign the values in that way over there. So for example, let's say the length of first string is L2, length of second string is L3, length of third string is L4, length of five string is L5. And let's say, like let's just assume L1 is less than equal to L2 is less than equal to L3 is less than equal to L4. And let's say we have somehow made this palindrome, this and this a palindrome. Then you will notice that, like let's say like this has five characters, this has six characters, this has eight characters, this has nine characters. So like we can remove the middle two characters from this string and we can swap it with this string to make the second string palindrome and like third string not a palindrome. Swap first three and last three characters from the third string. So L2 would be a palindrome and L3 will not be a palindrome. And now this would be the case. And now if you if you remove the middle character of the string and like if you swap the first four characters from L4 to L3 and last four characters from L3 to L4, then you will notice that now L3 would be a palindrome and L4 will not be a palindrome. Like my main claim is like we should always, okay, so like claim is start making palindrome from the smallest string. Because the number of characters you need to make a palindrome of the smaller length is less than the number of palindromes you need for a larger length. And like that is the main claim. And the reason is like if you can make, let's say, five palindrome from some different string, then you can always interchange those characters to make five palindromes of the smallest five string lengths over there. So like any questions on this one? Like if you want to maximize the number of palindromes, then like let's say if you want to make five palindromes, then we should pick the five strings which have smallest length over there. If you want to make 10 palindromes, then we should pick the strings of 10 smaller lengths over there. And once you realize this, the other part becomes a bit easier. And like what ABC, what I was explaining was like for each string, you finalize the characters which would appear in this string. And then the next claim was like how you can rearrange them to make it a string. So for example, if you have a six length string, then you need three characters that appear two times in that string, or one character which appears four times and one character that appears two times. If that is the case, then you can always rearrange that string to make it a palindrome. And for five, the cases were like two characters appear two times, two characters that one character two characters that appears two times and one character that appears once. And if that is how the string looks like, then you would be able to rearrange it to make it a palindrome. Or like the other case can be like one character appears four times and the other character appears only once. Then also you would be able to rearrange it to make it a palindrome. And the other case can be like the other two cases can be if a string contains one character that appears two times and one character that appears three times, then also you can rearrange it to make it a palindrome. Or like all five characters can also be equal. In that case also it would be a palindrome. So the important thing to notice, like this was the first claim, and the second claim is we only need frequency of each characters in a string to check if it can be made a palindrome. So like now I have two claims. One is if we want to make the smallest k number of palindromes, then we should try to make the k strings which have smaller lengths as a palindrome. And the second claim was for each string, if we want to check if we can make it a palindrome or not, we only need like the frequency, like how many times a particular character appears in that string, to say whether we can rearrange it to make a palindrome or not. And if these two are the cases, then let's say like suppose the strings in the increasing order is 5, 6, 8 and 9. Yes, we check with respect to the length and frequency of the characters. So for example, like if we want to check if we can make one string a palindrome or not, we check the smallest string, and here we need two characters even times. Whether we call it two character or one character two times is fine, so that we can arrange them as the first two character and the last two character, and one character for middle. And like if we want to make a 6 length palindrome, then we need three characters even times, like three characters in the starting and reverse of them in the end. So if you want to check if you want to make first two strings palindrome, you need five characters for prefix, you need five characters for the prefix and one character for the middle position. And if you can get it, then you would be able to make 5 and 6 the palindrome. So now then you check like for the 8 length frequency, you need 4 characters for prefix and the reverse of them as a suffix. So if you want to make first three strings equal, then you need 9 characters for prefix and same characters as a reverse and one character for the middle. And like I would be back in a minute. Like this was the main claim over here, then there were some conditions based on it. Okay. So like once you have conditions like this, you can iterate in increasing order of length of the strings, and you can keep a track of like how many characters you need in the middle, how many characters you need for the prefix, and the reverse of them for the suffix. And you can compare it against like how many characters appear odd number of times and how many characters appear even number of times, so you can make half of them. And like that was essentially the solution for this problem. Like once you know it, like you first arrange characters in between, and after that you arrange characters in the prefix and suffix, and if a particular condition holds, you increase the count and keep going. Yes, for the string of length 5, we should have two characters for prefix and reverse of for the suffix and one character in the middle. And for the 6, you need three characters for the prefix and reverse of them for the suffix. So if you want to make two palindromes for the length 5 and 6, you need five characters for the prefix and five characters for reverse of them for the suffix and one character for the middle. And like that was the idea. And like now if you know like overall count of all the characters, first you okay, like let's say you have strings of length 5, 6, 8 and 9. Then if you want to make like the 5 character string as the prefix, you need two character whether same or different that you can add in prefix and reverse them for the suffix part, and one character in the middle. and one character for middle position. And now if you want to make, after making 5 as palindrome, you also want to make the string 6 as a palindrome, then here you need 3 characters for prefix plus the reverse 3 more, same 3 characters for reverse suffix. So if you want to make 2 palindromes, one of length 5, one of length 6, you need 5 characters that you can add, 5 characters that you can add for the prefix, and the same part as the reverse, and one character for the middle position. And like if you can somehow get these 11 characters, you would be able to rearrange, swap whatever you want to make these palindromes. And once you have made these 2 palindromes, like you can try to see like if you can make a length 8 palindrome as well. For that you would need 4 characters for the prefix and 4 characters for the suffix. So if you now want to make 3 palindromes, one of length 5, one of length 6, one of length 8, then you need one character for the middle position, and 2 plus 3 plus 4, which is 9 characters for the prefix, and the same which you can put it in the reverse. And after you have made 3 characters of palindrome length 5, 6 and 8 as palindrome, if you want to also make 9 a palindrome, then you need 4 characters for the prefix, 4 same reverse characters for the suffix, and one character for the middle position. So overall, if you want to make 4 palindromes of length 5, 6, 8 and 9, you would need 2 plus 3 plus 4 plus 4 characters for the prefix, which is 13. 13 characters for the prefix, and reverse of them for the suffix, the same 13 characters, and 2 characters for the middle position. And if you notice this, then like you will see like we only need the frequency of each characters. Like for example, if you have A5, B3, then you know that using A, either you can put A 5 times in the middle, or 1 times for prefix suffix and 3 times in the middle, or 2 times for the prefix suffix and 1 time in the middle. If you have B 3 times, either you can put it 3 times in the middle, or 1 time in prefix suffix and 1 time in the middle. And let's say you have C as 8. You can either use 4 times in prefix suffix and 0 times in the middle, or 3 times in prefix suffix and 2 times in middle. 2 times or in prefix suffix, 4 times in the middle, or 1 times in prefix suffix and like 6 times in the middle, or 0 times in prefix suffix and 8 times in middle. So like what we can do is, like once we iterate on the increasing order, we will know how many characters we need for the middle position, how many characters we need for the prefix suffix. And we can also maintain a track like this, like how many times you can have a character for the prefix suffix, taking the maximum case for each of them. Like for example, you can take this as the first case, and if some characters remain, you can add 2 times for the middle part. Like you can start by maintaining this counter, and note that if you have an extra pair for prefix suffix, you can increase the middle characters by 2. Like you start with 4 prefix suffix, and if you use it only 2 times for prefix suffix, then you have a character which can be used in the middle 4 times. So like these would be the essential conditions you have. When I say C equal to 8, I mean that we have a one string of length 8 over there, which we want to make a palindrome. Or okay, wait, by c equal to 8, I mean we have a character c 8 times. So the question is like, how can we put it in different strings? So the way to use c which appears 8 times is we can either use it for 4c for the prefix part and 4c for the reverse suffix part, or we can use 3p for the prefix part and 3c for the prefix part and the reverse of for the three other 3c for reverse suffix and remaining 2c for the middle part. Like character c is 8 times in all the total strings you have, because like then you can swap them to make however you want. Like now, like I did two part. Like one part is counting like how many middle characters you need and how many characters you need in the prefix and reverse suffix. And the second part is counting all the characters, how many times they appear in all of the strings. Because like swap between any 2 points means like I can rearrange all the strings however I want. Yes, in all the strings, character C appear total 8 times. And like this was essentially the idea. Now, if I jump onto my code for this one, like I first counted like how many times a particular character appears by iterating over all the loops and iterating over all the strings, creating a frequency array. And I also created an array length which contains the length of all the strings. Then I took the extreme case where I am adding the only one character in the middle and I am counting how many times a character appears. So if a character appears odd number of times, I add f odd by 1. Like we can use that character once in the middle. And I'm adding f even by as a half. Like how many, in the worst case, like how many times I can get it in the middle part. These two variables. Now I have also sorted the length so far. And I'm maintaining two variables, odd and even. Odd is like, so if the length is odd, like I increase the number of characters required for the middle ones, and the remaining half is this one. And like I am first counting like how many minimum number of characters in the middle I can have and the maximum number of characters that I can have in prefix suffix. So if the maximum number of characters I can have in prefix suffix is more than the number of characters I need for the prefix suffix, then I break over here. Or like other way, and then I check extra prefix suffix, which is max prefix suffix minus the required prefix suffix so far. And then I make like I use all the characters for the middle position and the count increases by 2. Max prefix suffix minus minimum number of characters in the middle. If this is less than the number of characters required for middle, break it. Otherwise, it's possible. You add answer plus plus and continue. And at last, you return the answer. A dry run of the code once again. I have first counted the length of all the strings and sorted them in the increasing order. And now I am trying to make them prefix suffix. Along with that, I have counted like how many times a particular character appears in all the strings. And using that count, I am checking like minimum number of characters that are possible for me in the middle and the maximum number of characters I can use in prefix suffix. And after that, I am iterating in the increasing order and I am counting like how many characters I need middle and how many characters I need in prefix suffix part. And then I first check like maximum number of characters I can have for the prefix suffix. If it's more than the prefix suffix which I really need, then now it's not possible to make it, so break over here. Otherwise, use these characters in the prefix suffix and add the remaining characters for the middle character. And because you add one for prefix, one for reverse suffix, If you decide to use it in the middle part, you can increase the middle part by 2. So the extra characters I have, so multiply extra characters by 2 plus the minimum middle characters which we had, and check it with the number of characters we need in the middle. If it's more, then the answer is no. Otherwise, my claim is like it would be possible to arrange all the characters to have these many prefixes, and so print answer plus plus, and that has return the count. And this is essentially the code. Any questions on this one, or if you want to me to dry run some of the part again, I will do that before I move on to the last problem. And like this was essentially okay. Can I dry run on the samples? Sure. So for example, my samples were A, B, 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 A, A, A. So overall, I have B 4 times and A 4 times. So what my claim is, like we can use B 2 times for middle part and A 2 times for the middle part. We don't have any extra character lying around for the, sorry, if we, here we have A 4 times and B 4 times. So like we can use A 2 times for the prefix suffix and B 2 times for the prefix suffix, and we do not have any extra character lying around that can be used for the middle part. So prefix suffix count is 4 and extra middle character is 0. Now you sort the length of these strings in the increasing order 2 to 4. Now if you want to make 2 character string in the palindrome, you need 1 character for prefix suffix, and if you see it's 4. So like it's possible to make a palindrome of length 2. Now like once taken this, like we now we would check if we can make first 2 as a palindrome. Like to make second character as a palindrome, we need one more prefix suffix part over here. So overall we need 2 characters for the prefix suffix over here, but we have total 4 such characters. B 2 times, A 2 times. So it is possible to make a palindrome of the length 2. Now for the length of string 4, we need 2 characters for prefix suffix. And overall if we look, like we need total 4 characters for the prefix suffix, and we do have total 4 characters, so the answer is yes. And like to be honest, this is not a good sample to begin with. So I will rather try to pick some other example. Mhm. Let's say this is the other example where we want to count. Then if you count number of A's over here, 1, 2, 3, 4, 4 A are there. Number of B is 2. Number of C is 3. D, E, F appears one time. So like you can use A 4 times for the middle prefix suffix, B 1 time for the prefix suffix, and C you can say 1 time for the prefix suffix, and you have 4 extra characters for middle. 4 extra characters, once this and these 4. And if you look at these string lengths, these are 3, 4, 5. So here you need 1 for prefix suffix and 1 for the middle. And you can see like you can pick that 1 character from here and and 4 prefix suffix for this part. So like first, based on this frequency table, you have 4 characters for prefix suffix and 4 extra character for middle character. And because you only need one prefix suffix, you can directly pick these. And like now, if you have character 4, you need 2 characters for prefix suffix. So like you can pick like 3 characters. You can pick any 3 characters from the pool of 4 characters we had, and we can use one extra character for the middle part. And now if you look at 5, you need 2 for prefix suffix and 1 character for middle part. So overall you need 5 characters for the prefix suffix, but we have only 4. So the answer is no, like we will not be able to make 3 palindromes over here. Although we have required number for the middle, but the maximum prefix suffix we can have is only 4. And like that's why the answer is no for 3 palindromes, but yes for the 2 palindromes. And like if we look at the other case, where let's say we have 4 characters for prefix suffix and only 1 character for the middle part, and the palindromes and the string lengths are like let's say 3, 4, 5. What is the sum? 12. Let's say like we have this as the string length, and like what is their length? 12 plus 11, 23, 11 characters for prefix suffix. Like we can have this case, right, where one character appears odd time and all the other characters appear even number of times, and the increasing length is 3, 4, 5, and 11. So for the first string you need 1 for prefix suffix and 1 for the middle character, which is definitely possible because you have 11 characters for prefix suffix, 1 character for the middle. To make string 4 a palindrome, you need 2 characters for prefix suffix and 0 characters for the middle. That is also possible because you have 11 characters for prefix suffix, 1 character for the middle. And the problem starts when for the length 5, when you need 2 characters for prefix suffix but 1 character for the middle, but you have only 1 character for the middle. So what you can do is like you can first take these 5 characters you need from here, and you will remain with 5 characters from the prefix suffix, and you can use it to take 12 characters in the middle, and using plus 1, 13 middle characters are possible. Because you need only 2, the answer for this would also be yes. So with this as the starting combination, you would be able to make 3, 4, 5 as a prefix, like as palindromes over here. The idea is first fill the characters for the prefix suffix and then use the remaining characters for the middle part. And now if you need 11, you need 6 characters for prefix suffix and 1 character for the middle. And if you notice, like the sum of these would be 1, 2, 5, and 6. What would be 8, 10, 11? No, sorry, 5 characters for the prefix suffix. So here you need overall 10 for the prefix suffix. Because you have 11, this is possible, and you have 1 extra prefix suffix. So you use it to make 2 characters in the middle, and you also have 1 extra in the middle. So overall 3 in the middle. And because you need only 3 in the middle, that's also possible. So with this as the starting configuration, you would be able to make all of these as palindromes over here, and the answer would be 4 in that case. And like pretty much this was the idea. So like I will probably, let me just rewrite this code once again. I will use some meta variable. I have counted all the frequencies. If count is odd, the remaining characters for the prefix suffix. If length is odd, is greater than the character you have for prefix suffix. Now it's not possible, so break here. Like the total characters you had for prefix suffix minus the character you need for the prefix. And now if this required character for middle is more than the number of characters you have for the middle, it's not possible, break. Otherwise, and like this is essentially the code for this one. Now I will move to the last problem. Like, can you just count all the characters even times and distribute those evenly? Like this may not work, but if you try to binary search on the number of palindromes you have, then that idea may work over there. And I will move to the last problem of the day. Like we have already read the problem statement when we were reading the second problem, and the only difference is that the length of constraints is up to 1e6. And now here we would be using some string matching algorithms. For example, if you have 1, 2, 3, 4, 5, 6, like let's pick a better example. Like you have 1 4 4 1 3 5 5 3. Then instead of looking at the pattern first, let's try to find for each consecutive pair what character they can match. Because 1 is less than 4, this can match with one of the pattern, one value in the pattern. Because 4 and 4 are equal, this pair would match with 0 in the pattern. Because 4 is greater than 1, this character would match with -1 in the pattern. And because 1 is less than 3, like these two characters will match 1 in the pattern. And because 3 is less than 5, this part would match with 1 in the pattern. Because 5 and 5 are equal, this part would match with 0 in the pattern. And because 5 and because 5 is greater than this part would match with -1 in the pattern. So by looking at the original nums array, we can appear in this array, which would be 2 times. So the answer would be 2. So the first part of this problem looks like I got disconnected, but yeah. So what I am trying to do is I first look at the nums and find for each consecutive pair what character of pattern they can match with. And I create a nums array which is consist of -1, 0, and 1 to find all the patterns. Like for example, by looking at the sample, I was able to construct 1 0 -1, 1 0 1 -1, 1 1 0 1. And because my pattern was 1 0 -1, now I have to find how many times this appears in this string. And like that is the first part of the problem statement. And instead of 1 0 -1, I simply wrote it as characters ABC. Now, if we have these two patterns, what we need is like how many times nums appear over here. Like I can take the same brute force from the previous one for now. Now, instead of checking with nums, I can simply check Like TL is fine, but at least this works. And now what we need is like, given two arrays, we have to find like how many times the other character appears. And like that part I will mostly give as a reading exercise as a homework. Like there are many ways to do it. You can consider like these two arrays like nums pattern and pattern as strings, and you can use either async to see like how many times a particular like time matches over there, how many substrings pattern matches with nums pattern. You can also use KMP string matching algorithm as well. And like this is probably like, if you search for some problem, some classical problems, you will find it. Like the first application of like KMP algorithm is search for a substring in a string. Given a text t, like basically pattern in our case and a string s, we want to find and display the positions for all the occurrences s appears in this text. Like, and similarly, if we take t as our pattern and s as a nums pattern, we have to count how many times pattern appears in nums pattern. And like you can probably read it over here. Like overall, this would be the time complexity, and I will give it as an homework. And I will also add these links as a first comment. And like there are some really good YouTube tutorials to learn this as well. And what I feel is like this problem was in the reason why this problem was created was to use same as it is. So like, and with this pretty much completes my stream for today. If there are any other questions, I will take them. Otherwise, I will call it a day. Thanks everyone for joining. And since it's a hard problem, like you can expect there would be some prerequisite for it. Yeah, like there should be some way to use JAD algorithm, JAD function as well. Like one first algorithm for JAD function is also like search the substring like how many times it appears. Like JAD also works. Like first algorithm for JAD is also like how do you count this? So like counting like whether prefix of string appears in the second, like there are many ways to do it. And if you pick any algorithm to begin with, like you will find one way to do it over there. KMP works, JAD algorithm works, hashing works. And if you want to learn more advanced algorithms like which will never appear on Leetcode, then you can also use suffix arrays, suffix automations as well. But prefix function, JAD function, for now, the problems I have seen on Leetcode should be enough to solve hard Leetcode problem. Okay, like third character for middle. Like initially I counted like how many characters we have for prefix and suffix, which was half of the total frequency of each characters. And if some character appears odd number of times, let's say 3, 5, 7, 12, 3, 5, 7, 11, 13, something like that. In that case, we also had one extra character lying around as a middle character. Then I have sorted all the lengths and I'm looking in the increasing length. If the length is odd, then the required number of characters for the middle increases by 1. And like we also have a for loop for required number of characters for prefix suffix, which would be the half of the length of the given array. So the number of characters you need for prefix suffix is more than the number of characters you have for prefix suffix. Now you can no longer make a palindrome, so you should break over here. Otherwise, let's say we have used these many characters, and the difference between these two values is the extra characters which appear even number of times which are lying around. So using by taking the difference of them multiplying by 2, like if I r- take one character which is for prefix suffix and move it to the middle part, then the number of characters which I have middle for middle increases by 2. So let's say we have used these many characters for prefix suffix, so these many characters for prefix suffix, and we had originally these many characters. So we can look at their difference, and like we can pool those characters for the middle part and multiply it by 2, because we were taking it using them for one character 2 times for prefix suffix. Along with pulling those characters for the middle characters, we also add like the count, like how many characters we have extra lying around for the middle part from original case we had. And this is the count, like pool for the middle characters we have. Now we check like the number of characters we need for the middle part and compare it with how many characters we have remaining for the middle part, assuming like we have already filled the prefix suffix. If this is more, then we break like it's not possible. Otherwise, we say it's possible and increase the answer by 1. And like that was the main part over here. Like the character is like you fix up some strings which you want to make prefix suffix. You first fill the characters for the prefix suffix of those many strings. Let's say you are filling like 3, 5, 7, and then like whatever remains you check and fill it in the middle character. So like thanks everyone for joining.